Well, we're delighted to be here today, and thank you very much for the invitation for us to talk to you about this exciting book, Natural Security, edited by myself and Dr. Raphael Sagarin. I think by way of introduction, I think perhaps we each ought to say our own personal backgrounds, because I think it's very relevant to this book. I come from what I suppose you might describe as a security background, with the experience in the Army, the British Army, in different parts of the world, also working for the United Nations on inspections in places like Iraq and other places. And so my background is security, but I have a biological background in my work that I've done. The inspections in Iraq were part of the UN's investigations into the Iraqi biological weapons program. Yes, it really existed. And so that's my kind of background. And I was connected with Rafe, my friend and colleague here, who comes from a different background.
So my background is actually as a marine ecologist. I've mostly worked on the Pacific coast out at Hopkins Marine Lab, Stanford's Marine Laboratory in Santa Barbara, and working up and down the Pacific coast of Mexico and Alaska. And in the talk, I'll explain how I got it all involved in security. Currently, I'm at Duke University, where I work on environmental policy in the ocean, as well as on marine biology. So I already wear sort of a biology policy hat, but this foray into security was really the result of being able to work with people like Terry and some of the other people I'll talk about.
Okay. Now, I think just by way of introduction, Rafe is going to deliver the meat of the presentation. But just by way of introduction, just to remind you that we're in the 200th year of Charles Darwin's birth. It is the 150th year of the publication of The Origin of the Species. If you haven't read it, please read it. It's very accessible, even today. And it's not a piece of history. It's relevant for us today. And some people would say that it's the greatest scientific idea of all time. And a lot of people say that. And if you read the book, I think you will agree, and you will, I think, see its relevance today. And I think not only just as a general idea, but in the application of the thinking behind that idea, and drawing on 3.5 billion years of evolutionary history, there's something we can learn from that in a conceptual sense, in applying that in thinking about issues such as security, national security, international security, but also could apply in a big business setting as well. So any large structure that is facing various kinds of risks, I think would benefit from the kinds of thinking that Rafe is about to explain to you now. And so I'll let Rafe go ahead, and then of course we'll take some questions and expand. In my particular case, I apply this thinking every day in my work. It really does work, I can assure you. Maybe in question time we can explore that. Rafe.
Thanks. And I'll just mention that Terry's work brings together groups that you would not think would get together at all: Israelis, Palestinians, Jordanians, to work on infectious diseases in quite a complementary way. So that speaks to sort of this idea, nature of symbiosis, where there are things that get together in nature that you would think on the surface have no business being together and form quite successful partnerships. And Terry's group is really sort of living proof that that can be done in society. So I'm going to talk about, especially for this audience, before I get into the products of our group, a little bit in the process, because I imagine many of you are interested in sort of the process of how new ideas get put together, and I think guessing that's what a lot of you do in your daily work here. But it starts with sort of an idea, and this very compelling idea that came out of the 9/11 Commission report that's been often quoted, that 9/11 was basically a failure of our imagination. And I think that was certainly apt description of what happened leading up to and on 9/11. But the world has changed quite rapidly, obviously, since then. And we no longer have any kind of the same failure of imagination. I worked for a while in Washington, D.C., and one of the most peaceful places to go if you worked on Capitol Hill was down the hill to the botanical garden there. Used to be a place you could just walk into and end up in this rainforest, and it was fantastic. But of course now There's all the sorts of metal detectors and security guards you have to go through, just like any building in Washington. Someone's imagination has run wild and thought, someone's going to turn this into a fertilizer bomb and send molten glass up Capitol Hill. Likewise, we imagine that we could disable a jetliner with 3.5 ounces of mouthwash instead of 3 ounces. So we have these kind of security things. I think I want to bring up a point here. This is in a recent issue of New Scientist. There's a great article on sort of 8 myths of evolution. And one of the big ones that comes up over and over again in our studies is that there's a conception that evolution is about being perfect, about trending towards optimal solutions. And it's actually never about optimal solutions. They say you don't have to be perfectly adapted to survive. You just have to be as well adapted as your competitors are. The apparent perfection of animals is more a reflection of the poverty of our imaginations than of a reality. And where our imagination is failing us now is more in terms of what I call a failure of adaptation. And I bring a few anecdotes in here, security stories we've seen since 9/11. I'm sure all of you have your own, but this just sets the frame of this failure to adapt that we have. The building on the top left is a tiny facility of NOAA, the National Oceanic and Atmospheric Administration. The scientists there study fish and how to improve fish stocks for fishermen in North Carolina. It's co-located on a tiny island with the Duke Marine Lab, so I spend a lot of time there. NOAA rebuilt their facilities recently there, and as a result of being a government facility, they were forced to put up these huge Walmart-style parking lot lights in their tiny parking lot, their tiny dirt parking lot. And there's a gate on the island now and a camera that takes your picture every time you go on and off the island. Well, one major area of study that these guys do and that we do at the Duke Marine Lab is that light at nighttime is really bad for marine animals such as sea turtles that are migrating and figuring out where they're nesting, such as birds, shorebirds that are nesting and get disoriented by this bright light. So here is a case where a system that doesn't adapt, that says any government facility has to have this level of security, is totally inappropriate and actually runs counter to the research coming out of this very facility. More sort of trivial example, I guess. I mean, it could be a serious example, but I tried to send a package from Santa Barbara to Los Angeles, dropped it in the mail. 3 weeks later, it shows up at my desk at Duke University with a sticker on it saying you can't send a package over 16 ounces without handing it to a mail person. So now that package has passed through many, many, many mail facilities and gotten to me. And if I'm an adaptable terrorist or something, I'm thinking, OK, all I have to do is put the recipient's address in the return address field, drop it in the mailbox, and we're all set. So much for that level of security. Much more serious things we're seeing about failure to adapt to IEDs. And then recently, a couple days ago on the New York Times front page, states are now required that 25% of their funding from Department of Homeland Security must go to defenses against IEDs, which most state security experts are not thinking is very high on their list of threats. And they are vastly underfunded already in their mandate to conduct security operations. Now they're being asked, as a set priority, 25% has to go to IEDs, which is a hugely serious problem in Iraq, but not a serious problem stateside. Adaptation is really about leaving your comfort zone. And here's where I get into a little of the process of how this group got together. For me, my comfort zone were the tide pools in Monterey, where I spent a lot of my time studying invertebrates, their distributions, how they're changing in response to climate warming. But I always had this political interest in environmental policy, and I spent a year as a congressional science fellow in Washington, D.C., mostly working on environmental issues for Congresswoman Hilda Solis from East L.A. But I sort of couldn't get the naturalist out of me, and in fact, I needed to exercise that interest in looking at ecology and ecological systems, and all I had around me was Washington, D.C., rather than the tide pools. And I quickly sort of saw this ecology of fear that pervaded Washington, D.C. This was 2002, just after 9/11. And I put sort of my observations in ecological terms, seeing these Jersey barriers sprout like fungi around every sort of monument, seeing these massive increase in security guards and the armaments that they carried. But what I likened it all to was what I call fiddler crab security. Fiddler crabs, in this case to secure mates, which is a big aspect of security for animals. How can you secure access to promote your genetic material? Male fiddler crabs grow this one large, enormous claw, and they wave it at other male fiddler crabs in this kind of ritualistic display, and eventually one of the crabs backs down. They never actually fight with these things, but it's showing how much resources I can command by growing this enormous claw. These kind of competitive interactions are very common in nature, and they work very well if you have an opponent that has very similar resources available to it, that adapts in a similar fashion, that is, has sort of the same pathways by which it can adapt. Another hermit crab can't sort of all of a sudden grow wings and drop bombs on the hermit crab. They're all sort of escalating the size of their claw. And it has, what I put in quotes here as rational assumptions, that is, thinking about the problem in the same way that the opponent is. And also, importantly, that doesn't actually really want conflict. And so all of these things are very parallel to the kind of Cold War type conflict that we saw, these May Day parades of parading missiles and showing off our armaments and talking about a missile gap, but also understanding this in the context of mutually assured destruction if we actually use these missiles. None of these things really apply to the major threats to our security now, which are things like terrorism, things like emerging infectious diseases, and things like natural disasters and their aftermath. None of those things apply. So we need a new way of thinking about security, but a lot of our security responses have been in the old modality. And so I started compiling and thinking about the ways in which 3.5 billion years of evolution and over 20 million solutions to this basic problem. How do you survive and prosper in a hostile and unpredictable world? That's what biological organisms have been doing for 3.5 billion years. And I sort of summarized in a very short article in Foreign Policy a few years ago some of these ideas. But I realized very quickly, even as I was writing the article, that I knew almost nothing about security, and despite the fact that I know a lot about the invertebrates that live in tide pools in Monterey Bay, I know almost nothing about biology. And I think any honest biologist will tell you that they know almost nothing about biology because the field is so huge. So I realized I had to bring together people with very diverse backgrounds, both in security and on the biological side, to really get at these problems. What are the security problems we really face, and what are biological solutions to them from a number of perspectives. So I brought together a working group at the National Center for Ecological Analysis and Synthesis in Santa Barbara. It's a NSF-funded think tank. Normally, they do projects on what is the global impact of fishing, and they do very data-intensive projects where people bring together all their databases and try to figure the things out. But they took a chance on our working group, and it was a very successful working group where we brought in people that represent all these different kinds of fields for 3 and 4 day meetings over the course of a year. And a couple of important points about this kind of working group. One, just in terms of process that you may be interested in. I used this facilitation process called open space technology that's been pioneered by Harrison Owen. And he has a book, Open Space Technology. It's a real quick read, but it's a fantastic way if you're faced with this conundrum of how am I going to get people to talk that come from completely different fields, use different languages, and may have completely different assumptions going on. Well, you don't go into that group with an agenda and say, OK, guys, here we're going to talk about fiddler crabs, and then we're going to talk about coral reefs, and then we're going to talk about Alqaeda. What you do with open space technology is you pass out a bunch of big index cards and Sharpies, and you say, write something that you're really interested to talk about in this general area of overlap between security and biology. Maybe it's something you're really expert on and want to share. Maybe it's a question you've always had and have no idea how to answer it. You get all the cards back, you put them up on a board, and you start seeing the connections between the cards with the whole group. So the group is designing the agenda. And when you first propose this to any group, you'll get a lot of blank stares. You just say, come on, take the cap off your Sharpie and start writing. And they do, and you get 3 or 4 cards back. And very quickly, you start making an outline of how that group's going to go. And so we'd go to one group of cards and say, who wants to start the discussion? Because all these cards seem to be on a similar topic. Someone starts, and then the discussion never stopped over the course of the year that we were together in person and on email. It's an example of non-expert problem solving. So you've probably all heard of this paradox of the expert, that often you can get the absolute experts on a topic and they'll come up with absolutely the wrong solution to a problem. So it's very helpful to have people who aren't experts at a topic to give a different perspective. But as they say, you want your mind to be open, but not so open that your brain falls out. And what can happen if you just had a bunch of biologists in the room who had no idea about security is you might get some very naive ideas about security. So you also have this component of interdisciplinary collaboration, that people are truly cutting across their disciplinary boundaries to get into this problem. We had a huge, far-ranging discussion that went all over the map. And yet, what I found, I guess still talking about how broad it was, is that we found that you can apply this kind of thinking, taking lessons from evolution and ecology to security in a number of different ways. So we're not focused on one particular approach to doing this. You can use evolutionary and ecological analogies, and that's a very important and powerful tool. For example, looking at what the immune system does, the adaptive immune system, and how could, say, an intelligence gathering system function more like an adaptive immune system. So we'll talk in those kind of ways. Another approach that's being popular in a lot of different areas, not just in security, is this idea of biomimicry. So using ideas from nature and directly translating them into some different use. For example, looking at the hydrodynamics of a skipjack tuna and designing your submarine to match those kind of dimensions is one simple example of mimicry. There are others in computing, energy generation, medicine. We're increasingly looking at what biological systems do and how well they do it, and trying to mimic those outcomes. An important aspect of our working group was looking at the deep evolutionary root causes of what people do and why they do it, rather than just stopping at the level of saying, look at these crazy people around the world and what they're doing, getting beyond the historical perspective of what they're doing, down into the deep evolutionary history of why societies form the way they do, why the human mind formed the way they do. And this is a very powerful tool for uncovering and sort of breaking down the structures of how we think about these things in our popular discussions and getting a little deeper. And finally, there's been a lot of very powerful mathematical models that have been developed in the fields of evolution and ecology, everything from game theory to population models, looking at fisheries and this kind of thing. And we're exploring how much you can apply these to security situations. Here, one of the authors, Dominic Johnson, is using basic population models to look at how you might deal with an insurgency. Understanding all the time that you may have very different assumptions, but what you can do is use the models and then identify, here are the assumptions in an ecological model, here's what's different when you apply it to humans. So we're always aware of these translational kind of differences. We had all these ideas from all over the place, and it wasn't until I was actually writing the book, actually got all the chapters in from the co-authors, and then was writing the bookend chapters, the introduction and conclusion, that I actually felt confident that they could all be boiled down into a small number of basic themes, which I'll briefly talk about with some examples. So the first thing, and I think it's something that I hope will resonate here, is the power of organizational systems. And in particular, one of our working group members, Gary Vermeer, who's a paleobiologist at UC Davis. First of all, Vermeer is a fascinating character. He can identify probably more fossil and living invertebrates than probably, I would guess, anyone on Earth. And he has been blind since he was 3 years old. So he has this incredible observational sense. He's an incredible naturalist, but it all sort of gets translated through his hands. And the other reason why Vermeer is such an interesting character is he's really broken out of a narrow sort of focus on his science and has continually applied what he's learning from the fossils to questions in society. His latest book is Nature and Economic History, tying the history of nature to an economic system. So he was a natural contributor to this working group. And one of the things he finds overall out of looking at all these fossilized systems and living systems is that a structure of semi-autonomous parts with weak central control is the most flexible, adaptable, and reliable means of making unpredictable challenges predictable. And that's part of the key of dealing with an uncertain world, is trying to get a little certainty out of what you can do. And these systems, these organizational structures that are fairly allow a lot of autonomy to sensing units to sense and respond to the environment without constantly going up to a central controller are ubiquitous in nature, and they are the most adaptable kind of systems. And we see them at all different levels of biological organization, from systems below the organism level to whole organisms. You can look at the chromatophores of an octopus that can function very quickly in terms of mimicking the environment. You can look at colonial organisms where there are independent organisms, still part of a structure, but they have a lot of autonomy to do things like defense or reproduction or that kind of thing. And there are some ideas coming out of places like Princeton, Simon Levin, that ecosystems and networks of ecosystems and networks of proteins and cells, for example, also have something of this kind of structure. Our first major response to 9/11, probably the biggest response to 9/11 thus far, is to create this Department of Homeland Security, which is exactly the opposite of this kind of organizational structure. And as a rather simple but important exemplar of that, you can look at that circle in the org chart is FEMA. So FEMA, Federal Emergency Management Agency, is locked away in this very top-down hierarchical organization. And the first major test of security post 9/11, FEMA is heavily, heavily implicated, in actually the Department of Homeland Security, in the failure to respond to Hurricane Katrina. And that came out in the popular press. I've since confirmed that by talking to people like Governor Blanco in Louisiana and first responders who were down on the ground there. Not all of the blame by any means. You can definitely look at the fact that a natural system in Louisiana was supplanted by a highly unnatural system. But also a large part of the problem was the response locked into this unadaptable organizational structure. A good example that also comes out of government of how to use autonomous units to your advantage is the DARPA Grand Challenge, where this arm of the Department of Defense, which is charged with sort of promoting advanced projects, simply issued a challenge. Can you make a vehicle that can navigate independently a complex course? And rather than go to one military contractor that then would subcontract to a bunch of different subcontractors, they went out to basically to university groups and said, solve this problem. So it wasn't a whole bunch of university groups acting on their own and saying, make something cool for the military. It was, here's a problem. So there's a little bit of central control, but then all the problem solving was autonomously defined. And what you saw also is this ability for adaptation, because if you know anything about this grand challenge, the first year they ran it was sort of a disaster. Very few of the vehicles got very far, but by the second year, it was a very good success. Most of the vehicles finished the course. Stanford's entry is shown winning here. They learned from one another in that interaction during the first year and then went back and then autonomously resolved the problem. And this is a fraction of the cost of typical weapons development, a fraction of the time, and you had quite a bit of success there. I know this idea of convergent evolution here. This is the idea that often very interesting, important features in nature show up again and again, but have developed completely separately. So there are other authors and groups who have come across the same idea in different fields. I mentioned vermeil, but also in the field of business. This book, you may have come across, The Starfish and the Spider, talks about the unstoppable power of leaderless organizations. Paul Hawken's new book really focuses on social activism, but it's the same idea that this sort of bottom-up, autonomous small groups are solving big problems, big social, health, environmental problems in a completely different way than the typical sort of large environmental group or large UN body solving these problems. And in international governance, Jean-Francois Richard has talked about 20 major global problems that we solved. This is a former World Bank president who's suggesting that these problems need to be solved by these bottom-up sort of autonomous networks that emerge. And this is exactly what Terry's doing with the emerging infectious diseases networks that he's creating. Now, another aspect of what we're looking at, another broad theme, is in behavior. And we look at this in two ways. We look at what can we learn from animals, non-human animals. When are we like them? When are we not like them? What do they do? And we look at why do humans do what they do. And this gets at those evolutionary roots of human behavior. For all organisms, again, dealing with uncertainty, organisms want to reduce uncertainty for themselves and increase uncertainty for their adversary. That's almost universal in nature. So flocking behavior is a way to increase uncertainty for a predator that's trying to come into that flock. These killer whales that actually can basically ride waves up to the shore and grab these poor sea lions and then recede back into it is a very uncertain situation for a sea lion, because you don't expect a whale, a marine organism, to come up out on land and grab you. Some of the most terrifying and fascinating nature videos I've seen of those things. And periodic cicadas are a great example. These are bugs that come out in certain periods that different species have different periods, but they tend to be 13 years, 17 years. They're always a prime number. So by having this period when you emerge in masses as a prime number, it's very hard as a predator to create a cycle that will match up with that, with the cycling of the cicadas, increasing uncertainty for the adversary. We tend to do a lot of the opposite in our security responses. For example, we announce in huge billboards, terrorists, this is exactly what you cannot take on a plane, which reduces their uncertainty. OK, I can't take a liquid explosive anymore. I'll dehydrate it and rehydrate it with the ginger ale I get from the stewardess. This is exactly the opposite of what you want to do. We also do a lot of what I call nervous Nelly signaling. This comes from Dan Blumstein, a behavioral ecologist in our group, an author in the book, who studies marmots. Marmots are these big alpine, oversized squirrel kind of things. And what marmots do is they basically eat, they look out for predators, and they mate. And they do this in groups. And Blumstein studies them by sending in what he calls robo-badger, which is a stuffed badger on a 4x4 remote control truck chassis. And he sends that in and watches what the different marmots do. Now, there are some cool hand Lukes who only call when there's a real threat in the environment. Like a real, like a predator coming in. And then there are some he calls nervous Nellies that are constantly calling. And it's not always when there's a real threat or that the threat is imminent. And you would think there'd be this boy who cried wolf effect, that the other marmots in the group would start ignoring her. In fact, the other marmots in the group spend a lot more time trying to figure out if her signal is honest. And that's a lot less time they can have eating and mating. And we do a lot of that. We do a lot of nervous Nelly signaling. I don't remember the last time the security level at airports has been below orange. As a result, we don't really know what's going on. We have very little information. And so we're sort of always on guard. And we're obviously wasting a lot of resources when there's no actual threat. As an aside, I'll be absolutely panicked if I ever go in an airport and the security level is green. So there's a little problem with this detection signaling thing we have, because we also don't know what it means if they suddenly turn it down to green. The other aspect of behavior are these evolutionary roots of human behavior. A lot of the talk about security and international relationships is all in this historical context, which is talking about humans as if they've always lived in the kind of societies and governments that we live in now. But in fact, if you look at the whole history of life, humans make up about 0.04% of that history of life. And industrial humans, that is humans that live in the societies that we live in now, are just about 1% of human history. Almost all of our history has been in very small hunter-gatherer type societies that are completely different from what we do now. That's where our minds developed. That's where our societies developed and how we relate to other people developed. As John Tooby, evolutionary psychologist who is part of our group from Santa Barbara, says, our modern skulls house a Stone Age mind. What I like to say is trying to understand human relationships by looking at this little slice of industrial human society is like trying to understand War and Peace by reading The Last Word. If you translate the number of words in War and Peace to years on planet Earth, that's what it amounts to. That's the time we've been on Earth, the last word in War and Peace. So it's a very narrow, extremely narrow view of what we're doing. So we try to look at the deep, deep roots of human behaviors. And it goes all the way back to the earliest life on Earth, according to Luis Villarreal, a virologist from UC Irvine, who's been trying to figure out why do we hold belief systems and irrational beliefs so strongly. He is a Latino who came out of East LA, and he works at Irvine now, and he mentors young Latino students coming out of the same area. And he's always struggling with the fact that these are the brightest students he has, but they hold on to a lot of the belief systems that they grew up with, in this case, coming out of the Catholic Church and creationism and that kind of thing. And he cannot get even his best students to easily give up these things, no matter how many sort of rational facts he puts in front of them. So he started tracing back, where did this come from? And what it comes from is a need to identify your own group against another group, or as different from another group. And that need is so basic in life that it goes all the way back to the earliest bacteria fighting off viral parasites. And so that kind of what he calls an addiction module, a way of keeping yourself basically addicted to yourself as opposed to another type of organism, takes different forms all the way up through the evolution of life. So in lower primates, it takes the form of scent marking. Well, we don't do scent marking. We don't have that sensing ability as strong as lower primates, but we have this cognition, and then that turns into language and religion and those kind of things. That's how we identify groups against non-groups. John Tooby looks more at the modern context of how this now affects this Stone Age mind that's inside our modern skulls. And then operationalizing this on the ground, Scott Atran, an anthropologist, he studies people in the most intractable conflicts. He studies Palestinians and Israelis. He works with and interviews people who have committed to acts of jihad and said, I am going to kill myself for this cause. And he tries to figure out, how do you get beyond these strongly held belief systems? And it's not about breaking them down, it's about finding entry points. So he talks about making symbolic concessions in the understanding that you're not going to change people by throwing a bunch of facts or by throwing economic incentives in the way of these belief systems, because they have such deep roots. So we've got to find alternative pathways. Environmental awareness is a third big area that we talk about. And the basic concept here is that organisms live with risk. They implicitly understand in quotes, that they're living in a risk-filled environment. There's no sense in the environment that a shark is going to be anything but a shark. By contrast, in society, it's politically expedient to declare wars on risk, to say we can eliminate risk. We talk about a war on terror, a war on drugs, in my field, a war on invasive species. These are all generalized risks in the environment, and we're saying that we can get rid of 100% of them. We're sort of buoyed in this idea by past successes we've had against very, very huge risks in the environment, like smallpox, like fascism in Europe. And those successes give us the idea that we can get rid of these generalized risks. But if you think about those things, they're actually, although they were huge risks, they were fairly narrowly defined and things where we understood how to solve the problem. It may have taken a lot of resources and a lot of energy, but we knew how to do it. We don't know how to deal with getting rid of all generalized risk in the environment. And so I always put up a popular geologist t-shirt which says "Stop Plate Tectonics." It's sort of akin to doing that, trying to stop plate tectonics. With that sort of comic view, you realize that would just take a ridiculous amount of resources and probably have all sorts of ancillary effects that are very bad. And that's the way we have to look at these war on terror, war on risk type framework. It's not what organisms do. Organisms live with risk, and they live with it through adaptation. Here, species that have no business being together, a small fish and a predator that eats small fish, have established a symbiotic relationship. These are remoras that live with sharks. Organisms understand resource allocation. Peacocks do very well allocating a lot of their resources to reproduction and showing off how great they are to female peacocks if they live in an environment without predators. Once you start introducing predators, it's not very useful to have these enormous tail feathers because you don't even get to the point of mating before you get eaten. And organisms have a very keen understanding, a very nuanced understanding of risk in the environment. And that has been selected for, and there's some great emerging examples. One of them I'll talk about here, these squirrels. This came out in Proceedings in the National Academy of Sciences last year. Squirrels make signals to their predators to say, I know you're there and I know you're about to attack me, so I'm aware of it. You're not going to surprise me. But when they're signaling to birds and mammals, which can hear very well, they use alarm calls. And they say, hi, I know you're there. When they're signaling to snakes, they don't use alarm calls. They put up their tail and they make their tail bristles stand up and they wave their tail in this kind of display that sort of causes the snake to have second thoughts and back off. But not only that, when they're doing that with a gopher snake, they just put up their tail. When they're doing that with a rattlesnake, and that's what these IR images show, they heat up their tail because rattlesnakes, pit vipers, have heat sensing capabilities. And we know that because we read it in an encyclopedia. A squirrel has learned that through the process of selection, that if you heat up your tail, it sends a strong signal to a pit viper, but don't waste your time heating your tail to a gopher snake because it doesn't sense heat. It's an incredibly nuanced sense of the environment, and more examples of that are emerging. Cuttlefish, for example, communicate a lot with color, and they have completely different color displays for different types of predators. But while they're displaying to predators, they use polarized light to communicate to one another that their predators can't see. So they're making signals to each other, to other cuttlefish, saying the predator in the area through polarized light, and through visible light, they're making signals to predators. The final area that we talk about in applying evolutionary lessons to society is in the natural dynamics, the idea that the only constant in nature is change, but don't despair because there are patterns in change and they appear again and again, whether you're looking at cells, organisms, ecosystems, or whole evolutionary lineages of organisms. You see repeatedly this pattern of an origination period or a birth period, a growth or proliferative stage, and then a stage of senescence or death. And of course, it doesn't end there, because after the senescent or death part, you start all over again with new resources. So when that old growth forest goes down, you get a whole new succession of new organisms, for example. These raise all sorts of important questions that we need to be asking, and we're not asking enough in security. Things like, what type of organisms colonize a new area? We know in ecology there are different types. This blue line, this is time, and this would just be population of a plant, say. This blue plant would be what we call R-selected, a live fast, die young plant, a weedy type thing that comes into a broken down area, establishes itself fast, reproduces fast, and then dies off, as opposed to the type like a redwood tree that grows up long, starts commanding more and more resources, and ultimately becomes the dominant species in a given ecosystem, but over a long time period. The two have completely different strategies. And that's also the question, what types of condition give rise to new organisms? Where in the world should we be looking for new threats, and threats that may be fundamentally different from us? They may not be these K-selected type species that want to go and dominate the world slowly through a careful process. They may just want to make a big impact fast, and that's how they survive. So we've got to understand this diversity of approaches. And a key question is, at what point in this developmental cycle are we? These are zebra mussels that have grown on a shopping cart that was probably in Lake Michigan or something. This is a highly invasive mussel species. By the time we realized what a disaster these mussels growing on everything was for recreation, for shipping, just about everything that goes on in those waterways, they were so far in that proliferative stage that there was nothing we could do about it. So now, with invasive species, we have very aggressive campaigns to try to get them. First time you see a little sprig of invasive algae that some diver sees in a harbor in San Diego, it gets reported, and we try to eradicate it at that stage, because there's nothing you can do at the proliferative stage. And of course, these kind of spheres interact. They don't operate separately, and I'll just give a couple quick examples. The IED situation in Iraq is a really tragic example of bad organizational systems mixing with an understanding of the environment. Nearly from the time commanders stepped on the ground and were on the ground seeing what's going on in Iraq 5 years ago, they were saying, these IEDs are a major, major problem. This is what's really going to kill us here. And yet, you just heard a month or so ago these first reports of vehicles that were designed to respond to IEDs better than those Humvees getting out into the field. 5 years later, these MRAV vehicles that have V-shaped hulls that have adapted to the threat of ground-based bombs. So here, we understood the environment, but this organizational procurement system that everything had to go through and create these new vehicles is now sending out these vehicles, which, by the way, are likely going to be obsolete as soon as the makers of the IEDs adapt and recognize, OK, now we have this very slow-moving, very cumbersome vehicle. It's got a V-shaped hull. It's going to cause less destruction. Let's figure out something else. So we're always behind the curve. And tragically, about half the deaths in Iraq are caused by IEDs. Likewise, on the interaction of behavior and organization, Dominic Johnson and Elizabeth Maiden have a chapter in our book about how there are behavioral dispositions, again, evolutionarily derived, that make it difficult for us as humans to respond to major threats until after a catastrophic event like 9/11. And that is sort of reinforced by organizational structures that aren't adaptable. So here we're reinforcing both our Stone Age mind and its inability to calculate risk in the modern world, and organizational structures that don't respond well. On the flip side, when I think about airport security, we could use behavior to our advantage, which we don't, which is that we're terrible at calculating risk, and that's probably one reason why we screen 100% of passengers going through airports. But we're very good at assessing behavioral intent. And that goes back to living in small societies where you really had to know what a compatriot or someone coming in from another society nearby, what was their intent. So we have a very deep-seated understanding of human intent just by looking at people. And so there has been some early work and probably a lot of work going on that I don't know about on behavioral screening in airports, which shows a high degree of success. If you, say, look back at films of airports on the day of 9/11, screeners with a small amount of training in behavioral screening could say, that one, that one, that one, that one, and actually pick out all the 9/11 hijackers from films, not even live action. So I think there's some promise there. We're not seeing it happen. But in fact, mostly what we're doing is dynamically responding to a different stage of development of the threat. So we're taking away your shoes after we discovered a shoe bomber plot. We're taking away your liquids after we discovered a liquid plot. a plot to disable an airliner with a liquid explosive. So we're sort of behind that developmental curve of where our adversaries are going. So questions that always come up when you think about applying this stuff to human societies is, are humans really under evolutionary control at all? I was certainly a skeptic on this before working with this working group. I think there's a simple answer is you can look at millions and millions of people in this world for which life is a daily struggle for existence, not generally the people making decisions, but you can also look at these very compelling cases of understanding our deep evolutionary roots and understand that a lot of our behavior today is still under evolutionary control. At the same time, there are clearly a lot of areas where we're insulated from the daily process of selection on our systems. And in fact, our own governmental systems, our economic systems are very insulated from selection in a lot of ways. You'd like to think a democratic system, a capitalist system are very responsive to selection. But there's so many ways we insulate them, and that's where we become vulnerable because we're not testing them enough. And that's where we essentially need to take the reins and start controlling the evolution of these systems. And some people already are. There are bloggers out there who are sort of bragging about all the kind of contraband they've taken beyond enemy lines on airplanes. This guy likes to show off knives he's taken on board going right through security. But it's an excellent sort of selective test of what works and what doesn't work. And there are other systems you can conceive of that essentially are taking control of evolution and applying your own selection to security systems. So finally, there's a number of opportunities and challenges to bringing these ideas we have forward and bringing them into a policy kind of context or adopting them in business and that kind of thing. There's been very little adoption of sort of evolutionary ideas so far, but importantly, none of these ideas are classified. They're out there for anyone who wants to go out and study nature and see what nature does. There's nothing you can classify about that. And I go back to Ed Ricketts, who was a marine biologist in Monterey in the mid-20th century, a good friend of John Steinbeck's. He pops up in many of John Steinbeck's novels. But he was also very interested in the overlap between organisms in nature and problems in society, including security problems. And what he said, which is very important, he said, studying animal communities has this advantage. They're merely what they are for anyone to see and who will and can look clearly. They cannot complicate the picture by worded idealisms, by saying one thing and being another. So he's really getting this idea that we need to really look at nature in a very clear and unbiased manner and see what nature is telling us about these problems we're encountering. In this case, talking about security. So there's a lot of symbiosis that goes into this project, and these are many of the members of the working group and people that have worked with us along the way that I just want to thank. And Terry and I would be happy to take your questions. And thank you for coming out.
Any questions that anyone wants to raise?
Yeah.
So
you got a microphone coming. Yeah.
So what you're proposing seems to me to be diametrically opposed to the reactions and motivations of politicians, in the sense that they get rewarded for doing something, fixing the problem. You know, these sort of, what I want to say is low-touch reactions is not something that they seem to get rewarded for or think of.
I think, should I just start? I think you put your finger on a really key point. I don't think it's diametrically opposed. I would challenge that thought, although it may seem like it. But as you saw in the midst of Rafe's presentation, there needs to be a modification or an adaptation on their part to get the idea of living with risk. And one of the fundamental themes that comes out of all this work that's put together, and in fact, I think one of my favorite parts of the book, apart from Rafe's chapters and of course mine, is Gerard Vermeer's final paragraph, in which he makes clear that an organism that tries to eliminate all possible risks, is not going to be successful. And when you look at evolutionary history, not only think about the successes, you have to think about the failures as well. And that's hugely important. So if there's a message to the policy community, it's about the idea of not concentrating on one possible, this is one aspect, one possible catastrophic risk that might be less than 1%. You've all heard about the 1% doctrine, and I'm trying not to be political here, where you focus a lot of resources in trying to eliminate, remove that risk, international terrorism, a terrorist group delivering a nuclear weapon into a US city, maybe more than one US city. So you devote a lot of resources, which are not only economic resources, there are costs to society, costs to democracy and our ways of life and so on. And what you're doing by doing that is creating another vulnerability, probably an internal vulnerability within your own community and so on. So I think that's a message we want to get from this. So it's not diametrically opposed. But get this idea of living with risk. And I think also you saw in Ray's presentation how organisms have exploited risk to their own advantage by, I think, the classic case of increasing uncertainty for a predator. Because that's using risk in a positive way. We have a lot of sympathy with politicians and business leaders, and this is something, I mean, this is work in progress. We haven't got the answer. One of the hardest parts for me, who comes from a security community, who comes from advising ministers on what they should do about the range of risks that they're faced with, is how do we equip them that they can convey this message in a way that's convincing that will get them elected. That's what they're thinking about. And of course, it's very easy to say, with the policies I'm pursuing, we're going to eliminate that risk. It's unrealistic and raises expectations that can't be fulfilled. And worse, actually, I would say it was dangerous. And so in this process of dialogue that we created through this group, it's an open group that we want people to join. That's an aspect that came up actually in our talk yesterday. Was well, this is all very well, your terrific idea, but a politician has to do exactly what you just said.
And that's exactly why we wanted to talk here at Google, because rumor has it that there's a little bit of ability to take some risks built into the structure here. And I'm completely an outsider. I've read this Harvard Business School review, which also seemed to be two outsiders writing about Google. So I really wanted to hear from people here. Is that really part of the culture here? To allow for some risk-taking, which allows for adaptation. And that's why I said adaptation is about leaving your comfort zone. So anyway, I'm eager to hear from you about that.
So one of the things that came out of 9/11 was there was a lot of information at the ground level, and it didn't percolate up very well. And I'm wondering if there's good examples of natural systems that managed to get that fast-paced information filtering of what's relevant and condensing to the parts that are actually relevant to a pending risk.
Management of risk?
Yeah, that's a really good point, because the Department of Homeland Security was created to solve the right problem, which is exactly what you identified. The guy on the ground saying, there's a bunch of people here that I never see at flight school that want to learn how to fly a plane but not how to land it. That message never got up to the people that mattered. And so the idea was, let's put them all in one building and they'll communicate. But of course, that's not how the solution works. Natural systems that do this, I think the immune system is a good example. You do get signals up to the brain, and you do have all sorts of responses, even though it's mostly a system of autonomous units sensing the environment. You see this in colonial organisms that have different units that are sensing the environment in terms of predation, in terms of competing with other colonies, and how much to expand, how much energy to put into making stinging cells at the frontier of these colonies. Imagine sort of a colonial organism living on a rock and meeting another colonial organism, and the ones at the front have all the armaments. And that has to, be a resource allocation that then goes back to, okay, we need to spend time on defenses now, but if there's no other competing colony in the area, we can build up a lot more of the reproductive cells that do that. So these things happen. We don't completely understand how they happen. A lot of the work that's going on with some of the charismatic invertebrates I mentioned, squid, octopi and cuttlefish is a lot of the neurobiology work is trying to get at this. How do they do these amazing things that they do with color and conformity to different shapes of rocks and stuff and still maintain their organization as something you can call an octopus or a cuttlefish? This is really important. Again, I say not so open that your brain falls out. So we're not talking about a completely distributed system where everyone's off doing their own thing. There needs to be some central control, even just a statement of the problem that then everyone is out solving in their own way. So this is definitely an area for further research. We know that they do it. We don't know exactly how they do it in most cases.
In a human example, like a counterexample would be Alqaeda, which evolved its own immune system in response to the invasion of Afghanistan. So they went from a physical place that had central control. In other words, they had strong central control. But after the invasion of Afghanistan, they had to, as a reaction. It was an evolutionary process which mimics, I think, the biological world, where they have weak central control, their strategy direction, very, very general strategy direction, and autonomous cells, which are responding to this weak central direction. Weak in other words, are not strong lines of communication every day ringing up, go and blow up that church or that mosque or whatever. That doesn't happen. But the general direction, and they have evolved naturally as a response to the US and its allies and the way they've done it. That's an example in looking at it from an Al-Qaeda perspective. They've adapted. And whereas I think it would be fair to say in the United States, and it's not exclusive to the United States, I would say, perhaps it's the wrong word, we've retreated and strengthened the hierarchical structure. There's a danger we've gone in the opposite direction. And the opponent, has certain advantages as a result of what they've done. This is not a comment, was the invasion of Afghanistan the wrong thing to do? We can discuss that for a long time, but we have to think about the consequences of doing that and how the opponent will react and adapt to the new situation they're faced with.
Behind you.
In case of immune system, very often in medicine, they have to suppress immune system, otherwise the organism will die. So what you would say about that?
That's a great point.
Yeah.
I don't want to put the immune system up at a pedestal, because after all, some of the worst medical problems we have are either overexpression of the immune system or basically the enemy hijacking the immune system, as in an autoimmune disease. And to me, it's a very important lesson, especially if you're analogizing the immune system to, say, an intelligence gathering system. We need to be very aware that every evolutionary change, every activity in a body or in an ecosystem has consequences that filter out through the system. And sometimes they can be fairly negative consequences. So you have to look at, if you're going to create an intelligence gathering system, how much does the increased power you give to that sort of immunity have consequences for the rest of society, which might be something in civil liberties or something like that, to translate it. So there's always this potential for systems within the body or within the ecosystem to turn against, if you will, the functioning of the body or of the ecosystem. In ecosystems, if you give too much nutrients to a certain kind of organism, so climate change, as an example, people have argued, well, more carbon is great because plants grow better with more carbon. That's the simplistic answer. So more carbon, great, more plant growth. Then you learn it's actually plants like poison ivy. Those are selected things, those weedy things that grow much better with that increased carbon load. So it's not completely across the board. So we're always aware of what are the consequences from a perturbation to the system. It's not a single response. And so many of those early examples I showed you, the post office saying, oh, you've got to hand your envelope to a postal worker if it's more than 60 ounces, are single responses, one-time responses that we think that's going to solve the problem. But that doesn't solve the problem, because that response leads to a counter response and so on. And the immune system is just another example of an adaptive system where viruses that attack on the immune system have been selected through a continual escalation process to figure out how to use that immune system against the body and yet still maintain the life of the virus and the ability of the virus to reproduce. So it's a constant evolutionary game. So saying, do it like the immune system is not enough, because you've got to be aware of those consequences.
So I've heard that basically the Darwinian view of life made it possible to understand, organisms and ecosystems in a completely new way. And in fact, I think Richard Dawkins or someone else said, before 1865, any theories about life are completely useless, right? So you can see, you can view sort of a utility function that an organism is trying to optimize as sort of the survival and spread of its genes. So how can we apply this this sort of viewpoint to organisms like Al-Qaeda? What is the utility function that Al-Qaeda is trying to optimize? And can we either have them optimize the same function in a less destructive way, or use the utility function to hijack it, or something like that?
I'll let Terry mostly get into the details of that. I'll just mention quickly that we do get into that in a couple chapters in the book, especially Bradley Thayer's chapter, and Richard Sosis and Candace Alcorta have a chapter on religious beliefs and where these entry points are and how you essentially can insert at certain points alternative views. But I think Terry probably has a better perspective on what is that utility function of a group like Al-Qaeda, what keeps them reproducing and going.
Well, in a sense, I probably touched on it in an answer to an earlier question, and that their adaptation to their own environment, which is in a way was forced upon them, and that makes a kind of natural evolution to go to weak central control and the ability to accept losses. In other words, you need to be careful with the term optimize. Al-Qaeda doesn't go for the perfect solution and eliminating all its opponents. That's not what its objective is. Its objective is to inflict damage on an opponent in order that it might change its behavior, not to eliminate it. If you were to turn it around and look at US policy, the idea, I think it's accurate to say it's to eliminate Al-Qaeda. And that's probably such a high-level task, and the cost of doing that is, they're not going to be ultimately successful. And so I think what has happened with Al-Qaeda is its adaptation. It's multipolar, it's in different parts of the world, and it's very much an idea. And another aspect is, and this is something from evolutionary history, they have a long-term view. They don't have the next election, which in our democracies, there's this business of time, of providing solutions that have, this is going to be done in the next 5 years or next 4 years or whatever. So we limit ourselves by the very nature and structure of our everyday life, and somehow we have to balance this. And so I think I worry about the term optimal. You have to kind of define it very carefully. You accept injury to yourself, maybe as a group. You have to remind yourself what the objective is. It's to change the other's behavior. And maybe that's a lesson we could take from Al-Qaeda. We have to change the behavior of people who might get involved in these kinds of activities. So I think there's a real lesson, and it comes straight out of evolutionary biology, this 3.5 billion years that Rafe talks about. If you were to translate it into, just take it into the kind of everyday work that I try and do with my colleagues like Louise Gresham here in the audience, building on work done by Mark Smolinski, now with Google.org, but who laid the foundations of what we're doing with these networks. We have to try to take a long-term view. That's one thing. The second thing is that there's not strong central control. It's response to the demand of those places where you're doing the work to deal with biological risks that they're encountering. And the next level is you have to think along the whole spectrum of biological risks, from naturally occurring disease, things like antibiotic resistance, because that's where the man-made intervention altered millions of years of evolution, and we tinkered with it, and and there's very serious consequences yet to come. And then laboratory accidents, and then somebody deliberately using biology in some way, either biotechnology or the organisms themselves as a weapon. So we have to, this is a general approach in our everyday work, try to learn from these the kinds of concepts that derive from thinking about the history of evolution.
I should say that successful organisms have both general security approaches and specifically targeted.
Yeah.
So Dan Blumstein's also studied organisms that live in a place where predators have been absent for generations and generations. They still maintain the capacity to respond to those predators in many cases. If you bring the predators back in, they'll have that capacity again, as long as it doesn't cost too much to maintain that capacity. If it does, that's when you see the evolution losing things that you used to have in your past lineage. So it takes both sides of that, the full spectrum and the specific responses. Yeah.
Louise.
Are there any
Wait,
plans
hang on for a microphone.
Terry or Raphael, are there any plans to apply this more on a community basis so that people have what you referred to as a more nuanced sense of their environment? I suspect that that is what we often lack in our very controlled environments in the U.S., but in developing countries, I think they would have a better sense of their environment and risk, and that should be greatly respected. But I'm also thinking of a situation of genocide, where despite people's perception of their environments, they're not able to control, and nor do they often choose to control those environments. And Dr. Hamburg has just published a new book on genocide, the prevention of genocide, and those who side with Immanuel Kant and believe in some evil of people, no matter how much a sense of nuance people get, they may not be able to change their environment given this other force in there.
Well, that's absolutely true. I mean, animals go extinct. So that's, that suggests that just being aware of the environment isn't enough. I think Terry's already spoken to how important this local control of the programs that he's doing is, the local understanding of the environment. And the example I mentioned of Department of Homeland Security saying 25% of your resources has to go to this is exactly the opposite of this, because the Homeland Security chief in Massachusetts is saying, that's not my problem. My problem is X, Y, and Z. So, so more information is better, but it's not going to be a panacea. And you can have these systems that do go out of control, sometimes because of these very behavioral predispositions that are so deeply rooted that before the problem gets completely out of our control, before that catastrophic regime shift that Dominic Johnson talks about in his chapter, you get this. Genocide is a good example of a catastrophic regime shift that occurs, probably promulgated out of a core set of beliefs that no one could shake or offer an alternative way. But one of the things that's promising to me is both Richard Sosis's chapter and Scott Atran's chapter, and subsequent work that Scott Atran has done, shows that there are pathways to entry and pathways to open up the door. And the trivial and fun example I give is what we call ping pong diplomacy. When we wanted in the 70s to open relationships with China, we didn't say, you must modernize, you must open up your doors. One of the things we did, I wouldn't say this is all of it, but one of the things we did is we sent a bunch of ping pong players to China. It's a great strategy because sending ping pong players to China get their asses kicked by the Chinese didn't cost the US anything, because no one cared that our best ping pong players lost to the Chinese's third string of ping pong players. It was a glorious, wonderful victory for the Chinese. And what it did is it opened up the door to say, we're willing to give a little if you're willing to give a little. On a more serious note, this is exactly what Atran's talking about with the Israelis and Palestinians, and has done simulations with Palestinians and Israelis showing that very simple concessions that governments are still loath to do. They might be things like apologizing for collateral damage due to a bombing or something, can go a very long way, much longer and much farther than saying, you've got to drop that thing that you want. That's not okay with us, because they're not going to change that fundamental belief if they believe a certain set of conditions. So there are abilities to get in there, but you have to consider the timing. Once it's gone into that genocide phase, you actually may be too late. You're already in that proliferative stage.
I think that's a very interesting example. I mean, the case you're talking about, like, for example, the fascist regime in Germany and the mass extermination or the attempted mass extermination of Jews in that country and other countries as well. That's an aberration and an overreaction to a set of circumstances. You could look at that like the immune system going awry, that a deep-seated set of beliefs are challenged. And then there's a misperception of how you would deal with that challenge to your deep-seated beliefs, and you get these terrible reactions. I mean, in a different way, if you think of the mass suicide of the Jonestown, in Guyana,
absolutely,
where they felt their deep-seated beliefs were being challenged, and somehow someone managed to convince a group to do this. But the roots lie in the human evolution, and that chapter that we have in the book on that subject. So one has to handle these deep-seated beliefs very carefully, because you'll cause the overreaction, which was extraordinarily dangerous. And we find pathways by which you can communicate. And as you do, Louise, with us, we found a pathway, and as Mark has done, between Israelis and Palestinians on a particular issue where there's a convergence of interests. It's not challenging their deep-seated beliefs. It's not challenging the existence of Israel. It's not that at all. It's about human communities have a common interest in improving important issues of public health.
So you've kind of commented it to this point just a little bit, but so now that you've written the book, how will you promote it to politicians and people making policy decisions, who actually I would imagine would be not likely to pick up this book at all?
Yeah. So the question was, how now are we going to promote this to politicians and decision makers who are probably not likely to pick up an academic press book? We wanted to get, first of all, we wanted to get the ideas out there in some forum. So I worked with the University of California Press, which is not a great promoter of anything. They make books, they don't promote them. So we're doing a number of different approaches. One is talking to groups like this in business. Yesterday we were with a security group at Stanford. We've talked to security think tanks in Washington, D.C. We've talked to scientific groups in Washington, D.C., like IIIS. We'll be doing congressional briefings for those staffers whose bosses are involved in the security committees and that kind of thing. So it's a multi-pronged approach. I'm currently working on, sort of the Jared Diamond version, the mass market version of this book, which is a more accessible approach. It's sort of everything. It's a marketing. I mean, any ideas need to be marketed in some way. So we recognize the challenge there. And we were just talking yesterday with Senator Gary Hart, who's been very involved in Homeland Security since way before 9/11 with the Hart-Rudman Commission. And he had some very good advice about what sort of products you can put out that really resonate or are accessible to policymakers. And my day job is basically doing this for marine environmental policy, trying to figure out how to translate science that I'm doing and other scientists are doing to a language that policymakers and the public can appreciate. So I'm getting well versed in this, and I'll apply the sort of same approaches to this book. Right now, it's still also a process of getting new ideas. Every time I talk to new audiences, I get a new idea or something new that someone suggests. Oh, have you thought about this system? Or I study these little bugs, and they do this, which is really cool. So that's why it's so important for us to have these conversations.
And we want to add to the names on this list.
Yeah, right.
And have a look at www.darwiniansecurity.org, which is a website created by Rafe.
Yeah, darwiniansecurity.com.
.com.
.com and .org. We got them all.
We got them all, yes.
We couldn't get natural
That's
security.
where we want ideas from people like you.
Yeah.
So,
thanks for mentioning that.
Yeah, well, it's kind of a long question. It's about the modeling that you did for the colonial immunity systems to the government. So I was asking if there is any organism that basically work. In any colony, there are like two organisms that stick to each other, and one of them act as the immunity system for the other one, while it's not necessarily its utility function.
Yeah, it has a utility function.
It's actually utility function is to survive rather than to provide immunity, because
absolutely
this modeling there. Well, since you're
please.
It's okay. Since you're from UC Santa Barbara, like you lived there for a while, Professor Ammar, Paul Ammar,
He's from Law and Society Department.
Oh, okay.
And what he does is basically he's studying the police, and basically what he's trying to show is that the police as a system is not there to protect people more than to exist and to enforce governmental policies.
Mm-hmm.
So I was asking if something like this is there in nature.
Yeah, so the question is,
Thank you.
Are there examples where something is, sort of appears to be providing some immunity, but is actually there for its own function as an organism that's in a relationship with another organism? And the example given was police as something that supposedly provides immunity against crime, but is actually an organism on itself that has its own goals to reproduce itself and support a governmental system. Absolutely. Symbiosis. There are millions of forms of symbiosis, as many as there are organisms on Earth or more, because you get into factorial kind of things. Takes a multitude of different forms. And you can go back in history. We have tons of genetic parasites within our own DNA that were once symbiotic relationships that became fully incorporated into our DNA. So you can look at our genetic code and find almost exact matches to viruses and that sort of thing that once were sort of free riders and then eventually got incorporated into our genome. And there are countless examples. People consider mitochondria to be one of these examples of once an independent organism that then got incorporated into our cell structure. And importantly, on your point, many symbioses are not these sort of mutually altruistic kind of things. They are the organism in it for its own good and reproduction, and sometimes it behooves the organism to become a full incorporated part of the host organism, and sometimes it's a temporary relationship that can run awry. There's a great example where there are symbiotic bacteria that help plants. But it turns out that if they fail to help plants producing nutrients, the plant will punish it by withholding oxygen from those organisms. So, so these relationships can be very tenuous. They can be very temporary, or they can be so long as to become fully incorporated into the genome of the host organization. So almost anything goes when it comes to symbiotic relationships. So there's no one answer to your question. Thank you.
And that's a really good question. And if you look into the security world, and by the way, whilst security has really been the focus of what's brought us together, this would apply in the business world too, large corporations and so on. So while I'm going to make a security example, if you were to take the Iraq case, and I'm trying not to be political, but analytical, there was a concentration on force protection for the U.S. forces in Iraq. So the mission was to protect, unintentionally, was to protect U.S. forces in Iraq and not to protect the Iraqi people. And that was, really a fundamental problem until the policy changed with General Petraeus going, and he changed the tactic. It required more troops. Of course, we needed more troops right from the beginning. And so the different tactic. So you have to provide security for the Iraqi people and do collaboration with local groups and so on. And there are many other lessons in the UK case in Northern Ireland. There's another example where a completely different approach was taken. And if you were to compare the counterinsurgency campaign in Malaya, going back some time, and Vietnam, the two different ways. And in Vietnam, it ended up with force protection again being a key factor, and the big fire bases, not living with the community, whereas in the Malayan case, because UK is not such a rich country, had very limited resources, had to go and live in the community and advance the security of the community, give them advice on agriculture and all these other things. They were delivering security. They got the idea these forces are here actually to make our lives better and safer. So it's a completely different approach. And that's what counterinsurgencies should be all about. And that's a lesson from evolutionary history.
That's a great example, protecting the force rather than the goal there. All right, well, thank you all. I want to thank Michael Oswald, who is our host here, recently brought into the Googleplex, I guess. And it was great to have that entree into your opinions and ideas. Please contact me. I'm Rafe.Sagarin at Duke. Michael can put you in touch if you forget that. I would love to hear more from you about how you're working here is going and how that might relate to these kind of adaptive structures. But I really appreciate your questions and your coming here. Thanks.
Thank you very much, and buy the book.